Assalamualaikum and a very good day. I am Muhammad Firdaus bin Muhammad Ali, and on behalf of my team from the Faculty of Creative Technology and Heritage from Universiti Malaysia Kelantan, we are proud to present our innovation title is C Flat Fit 3D Insole. C Flat Fit 3D Insole means C is for children, flat is referred to flat foot, the condition targeted. Fit implies proper fitting and support for children's feet, and 3D insole indicates that the insole is produced using 3D printing technology. C-flat fit 3D insole refers to a 3D printed orthotic insole specially designed for children with flat foot. It's offering a range of arch support options to ensure the best possible fits, comfort, and biomechanical correction, and combined with cutting-edge technology and practical design to address real clinical needs in pediatric foot. This project is led by experts from Faculty of Creative Technology and Heritage from Universiti Malaysia Kelantan, comprising specialists in creative technologies, design, biomechanics, and also the healthcare application. So, let me begin with the highlighting the introduction. So, what you can see from the screen, these are the rare examples of flat foot in children. On the left, you will notice a children with no visible arch where the entire foot pressing flat against the ground. This is a classic sign of flexible flat foot. Most babies are actually born with flat feet and is not immediately a medical concern. As they grow, the foot arch typically develops during the first 10 years of life, often spontaneously. However, 1 in 5 children may never develop a proper arch, and that's where intervention becomes necessary. If left unmanaged, it can lead to improper gait, early fatigue, joint pain, and even long-term structural problems. On the right side of the slide, we have image showing a more severe and rare condition called congenital vertical talus. This condition is rigid and more serious than typical flat foot. The red curve highlights how the talus bone is abnormal aligned causes the foot to bend outward. Children with this condition often require surgery and intensive therapy. Now, while most cases of flat foot are flexible and manageable, the challenge lies in early diagnosis and affordable intervention. Many children, especially in rural or lower-income communities, don't receive timely care. Now, let's take a closer look at the clinical presentation of flat foot. As shown in this image, on the bottom left, we see a comparison between a normal arch and also the flat arch. In a normal foot, there's a visible gap between the midfoot and the ground. That's the longitudinal arch. In contrast, a flat foot completely collapses onto the floor, reduces shock absorptions, and changing the foot entire mechanics. If you look at the photo in the middle, we can observe a real children's foot with no visible arch when standing. The red arrow indicates full contact with the ground, which is a textbook example of flexible flat foot. Moving to the top right, this image shows another children's foot from the side, again demonstrate arch depressions and medial foot bulging. These signs are often overlooked in early years, especially because some children don't complain of pain immediately, but over time it can lead to fatigue, gait abnormalities, and even knee or hip issues. The heel view at the bottom right is particularly important. Notice how the heel tilts upward, a condition called heel valgus. This misalignment shifts body weight improperly during walking and can lead to ankle instability or long-term discomfort. Finally, on the left, we are drawn a dashed line down from the leg to the heel. In the healthy foot, this line should be straight, but in flat foot children, you can clearly see a valgus angle. The heel bones rotates outward further, confirming the diagnosis. So, what do these results tell us? That even a mild flat foot, there are visible biomechanical changes, and without timely intervention, this can progress and affect a children's ability to walk, run, and also play normally. Flat foot may seem like a temporary issue in childhood, but in many cases it persists into adolescence and adulthood, leading to complications if not properly managed. On the left side, we list several contribution factors to tense flat foots. The first one is genetic tendency. Flat foot often runs in families. Joint of ligament laxity. Children with loose joint tend to have unstable foot arcs that collapse easily. Obesity, increased body weight exerts additional pressure on the developing arcs, worsening pronation. The fourth is neuromuscular conditions such as cerebral palsy, often result in poor muscle tone and foot structural control. And finally, in more several cases, rigid flat foot caused by conditions like tarsal coalition limits flexibility, entirely requiring specialist care. The top of the on the right show a children standing flat, and we can see from the red arrow the arch is completely absent. But when the student is asked to tiptoe, there's still no visible arch recovery, confirming the rigidity of the condition. This is important clinical indication in a flexible flat foot. The arch should partially reappear during toe standing. If not, we are dealing with more serious structural issue. Now look at the bottom six of image and the height of arcs. This illustrates the range of arch condition from completely flat to mild and normal arcs. So some children have flat arcs that look normal at rest but collapse under load. Others present with presenting foot collapse even during non-weight bearing movement. This variation makes one size fits all insole effective, and is exactly why our C flat foot 3D insole was created with different support profile customized to individual arch condition and stiffness level. Now let's talk about intervention, especially arch support and insole, and how crucial they are managing flat foot. On the left side, you'll see the two types of insole. The first is firm insole that are designed to support the arch, correct pronations, and also stabilize the foot during motion. And the second one is soft cushion insole. This offer comfort and short observation, but more not provide adequate structural correction, especially for children with moderate to severe foot. This highlights an important point. Not all insoles are created equal. What works for comfort may not work for correction, and may over-the-counter insoles fail to meet biomechanical needs for children with presence of systematic flat foot. Moving the right image, we have a powerful real-world indicator. So when we can see from the pair of shoes, you'll notice that excessive wear on the inner side of the sole. This is classic sign of overpronations caused by flat foot. These children will not be being distributed evenly. Instead of flowing naturally through the outer edge and arch, it collapses inwards, stressing the ankle, knee, and even the hip over time. This is where early detection and proper support matter. So our solution, the C flat foot 3D insole, offer not just cushion but tailored biomechanical correction through 3D printing, furnish zones, customizable arch height, and adaptive flexibility. In other words, it's designed to treat the cause, not just a symptom. Our objective are threefold. First is to develop insole with different arch stiffness level to match flat foot severity. The second one is to reduce cost and simplify production through 3D printing. And third one is to enhance the quality of life for children by offering a clinically relevant and affordable solution. So this is our research flow for this product. Okay, we started with the ethic approval, and also we do a data collection, and we divide into two. The first one is therapists in the hospital, and also the preschool. Okay, so we started at we work closely with pediatric therapists who provided insight into common treatment protocol and physical activity routines. We also do some preschool level identifying children with early signs of flat foot, and we then compare with this limitation of traditional insole, which are often generally non-adjustable and not designed with child specific biomechanics in mind. This workflow helps us build a solution that is grounded in clinical reality, yet forward-looking in terms of design and fabrication. Preschool, located in the district of Kota Baru and Besut, was selected as the initial testing site to observe the real-world application of the C flat foot 3D insole for children. During the
Okay,
phase,
kita dekat
we
cikgu
focus
balik.
on two primary aspects, the children's foot
Okay,
structure and their movement pattern, particularly
Right.
during the walking and also running. Among the 10 children observed, 3 were identified as having flat foot. Interestingly, this was the first time the condition was recognized by the teacher, highlighting the insole potential not only as a supportive device, but also as a tool for early detection and intervention through school-based screening. We also collaborated with therapists for expert input on treatment effects, incorporating physical activity to evaluate muscle engagement and support movement. Our therapist is from Hospital Raja Perempuan Zainab II in Kota Baru, is Mrs. Juliana and Mr. Faisal as occupational therapist, and also Hospital University Sultan Zainal Abidin with the Dr. Nuriza. So this is an example of the treatment and physical activity that be conducted for helping the children to face that facing the flat foot problem. The first picture is using the towel, marble, and also the small ball.
Itu lagi. Okey.
Buat apa sana?
Okey, betul.
Tak payah. Tak pandai.
So this is the traditional insole often used plastazot, a cross-linked polyethylene form commonly provided by therapists in Hospital Raja Perempuan Zainab II in Kota Baru, is inserted into the children's shoes to help manage flat foot condition. However, these insoles are not durable and tend to wear out quickly as they are typically assembled using adhesive alone, which comprising their structural integrity over time. So this is our C Flatfoot 3D insole, a lightweight and flexible insole designed specially for children with flat foot. It features built-in arch support to correct alignment, perforated section for airflow, and flexibility and curved edge for pressure distribution. It made using a TPU 95A. It is a soft yet supportive and perfect for growing feet. Most importantly, this product supports SDG Code 3 for promoting children's health and early interventions. It is affordable, customizable, and ready to support better foot health. The C Flat Fit 3D insole comes in 3 biomechanical engineered design, each offering unique properties. The first one, you can see, it called the cross pattern. It designed for enhanced cushion and to absorb impact during walking and running. It is ideal for children who are active in early stage of correction. The second is linear strip reinforcements. This adds structural support, providing the right amount of stiffness to help guide foot arch development and maintain alignments during movement. And the third one is perforated lattice design, offer maximum breathability, keeping the foot cool while still maintaining the adaptive flexibility for comfort. So by combining the functional zones within the insole and tuning the geometry and thickness, we create a solution that is not only lightweight and breathable, but also capable of delivering precise biomechanical correction in a single integrated product. So the material that selected for this C Flat Fit 3D insole is thermoplastic polyethylene TPU 95A. It is for the flexibility, durability, and comfort, and is ideal for pediatric use and is allow effective shock absorptions while maintaining arch structure. As you shown in the image, you can see that the heel alignment is corrected and the arch is lifted. Foot posture is improved and resulting in better balance, reduced strain, and healthier walking pattern for the children. So the C Flat Fit 3D insole stand out for 5 reasons. The first one, the evidence-based design. The second is precision customization using 3D printing. The third is high quality, hypoallergenic material. The fourth is continuous R&D for improvement. And the fifth is developed in collaboration with pediatric and orthopedic experts. We are currently at TRL6, which means the technology has been demonstrated in a relevant environment and is moving towards system development TRL7. We are well positioned for commercial scalability backed by a commercialization grant from Yayasan Muhibah Tan Sri Feng Aseng. We get this year. At the same time, we are in the process of obtaining Medical Device Authority (MDA) approval. This is a key step to ensure compliance and readiness for mass market adoption. Our project has established an official cooperation with Fabricas Berhad, which is a 3D printing technology company to co-develop custom 3D printed insole tailor for children with flat feet. This partnership allows us to rapidly prototype and iterate to our insole design using advanced additive manufacturing. Additionally, we are currently in the process of initiating a new partnership with BioApps dan Berhad, a specialist orthotics company under Universiti Malaya, to explore clinical trial and further refinements of the insole for pediatric orthopedic use. We also are protected under Malaysian Intellectual Property Law with application number LY2024 WO3379 copyright to ensuring freedom to operate and commercial readiness. So we also proud to share that this 3C flat feet won several innovation awards, including the Best Innovations and Gold Award at iCompact last year, 2024, and a silver at UMK Carnival Research Innovation. This research has been disseminated through two academic scopus proceedings in ICITS 2023 and 2024, document both design methodology and finite element modeling, contributing to scholarly and clinical knowledge. We sincerely thank to our founders, UMK Prototype Research Grant, and also the Dana Innovation, Yayasan Muhibah Tan Sri Feng Aseng, for supporting this impactful initiative. And we also thanks to our academic and clinical collaborator for this product. And lastly, thank you for the attention and interest in our project. We believe that the C flat fit 3D insole offer a meaningful step forward in pediatric orthotics care, combining innovations, accessibility, and clinical relevance. We sincerely appreciate the support from our institutions, collaborators, and funding agency, and we look forward to opportunity to bring this solution to a wider community. Thank you.